Hi everyone, this is your Aparna ma'am. In our last video, we already discussed about Sn1 reaction. Now we are going to discuss about Sn2 reaction, means bimolecular nucleophilic substitution reaction. In this reaction, when methyl halide is reacted with potassium iodide in presence of acetone, it gives rise to methyl alcohol and halide ion. The mechanism of the reaction like this. In this reaction, the nucleophile attack to the alkyl halide from the side opposite to the halogen atom. This attack is called as rear side attack or back side attack. It forms the transition state. Finally, this transition state, it gives product methyl alcohol and halide ion. As I mentioned earlier, this mechanism has only one step. Therefore, here the rate of reaction depends on both the reactant, means concentration of both the reactant. The rate depends on concentration of nucleophile as well as alkyl halide. Therefore, this reaction follows second order kinetics. This is second order reaction. There is no formation of carbocation, means in Sn1 reaction there is a formation of carbocation. Here we get a transition state, and this transition state cannot be isolated from the reaction. Here nucleophile, this OH minus, donates the lone pair of electron to the anti-bonding molecular orbital of carbon atom. And in this reaction, the solvent used are polar aprotic solvent, say for example acetone, DMF and DMSO. These are polar aprotic solvents. And as Sn1 reaction, this is also exothermic and favors at low temperature. And here stereochemistry is inversion, means attack of nucleophile from the backside. Therefore, inversion of configuration takes place. This is known as Weldon inversion. Factors affecting Sn2 reaction. Here, rate is inversely proportional to steric hindrance, means if alkyl halide is least steric hindered and rate is high. Here there is a methyl halide. Here tertiary methyl halide is there. Here carbon is attached by the 3 bulkier groups. Here carbon is attached by 3 hydrogen. Therefore, this methyl halide is less steric hindered compared to the tertiary halide. Therefore, this is more reactive. And the second point is stability of transition state. Stability of transition state, how it is stable and rate of reaction is high. And in these two factors, stability of transition state, it predominates over steric hindrance. Next factor is nature of nucleophile. If higher the concentration of nucleophile and the rate increases, means if we use a strong nucleophile, Sn2 reaction favors easily. In presence of strong nucleophile, Sn2 reaction carried out easily. Take some examples. Okay, in first example, okay, take down this example. In this example, there is a primary halide. If it is primary, then this is Sn2 reaction. It gives rise to methyl alcohol. And this is tertiary. Here Sn1 reaction takes place. Again it gives rise to tertiary methyl alcohol. Again this is also primary. Primary means Sn2, and this is secondary. Secondary means there is a possibility of both Sn1 and Sn2. So this reaction decided by the solvent we used. If we used DMF, then this is Sn2 reaction. Therefore, product is like this. If we used water, this is Sn1 reaction. We get both inversion and retention of the configuration. This is retention. This is inversion of the configuration, means we get racemization. Thank you everyone.